Okay, so this is Unit 3, Lesson 2. We're going to be learning a lot about perpendicular and relationships amongst angles. So, if we look at number 1, we're given that angle 1 is congruent to angle 3. So let's mark those in the picture. And we want to prove that angle 2 is congruent to angle 4. Okay, you're going to memorize this procedure because this is always going to come together embedded in a larger proof. So you start off with your given. Angle 1 is congruent to angle 3. But keep in mind you're also given the picture. So then you have to establish that angle 1 and angle 2 are a linear pair. Right? So since they're a linear pair, they're supplementary, right? So angle 1 and angle 2 are supplementary. And angle 3 and angle 4 are supplementary. You can abbreviate supplementary if you want. Okay, so the reason that these are supplementary is because you have linear pairs. Linear pairs are supplementary. Now you can write that out, or you can just do what I did, make this a little flow chart, linear pairs, then they're supplementary. So with this proof, you can now jump and say that angle 2 is congruent to angle 4. And let me explain the reason. Okay, so let's just pretend that angle 1 is 125 degrees, okay? So angle 3 would be 125 degrees. Now, we know that angle 1 and angle 2 are supplementary, right? So that means that angle 2 is 55 degrees. 180 minus 125. Angle 4 is also 55 degrees because angle 3 is 125. And that is also a linear pair, so they are supplementary. So think about it. Angle 2 is congruent to angle 4, right? Well, didn't they end up being congruent because weren't they both supplementary to angles which were congruent? So the statement you need to memorize is that supplements of congruent angles are congruent. And this is going to come up a lot, okay? So keep that in mind. Okay, so pause the video and copy down the picture, the given, and the proof for number 2, and then come back and watch the video. Here we go. So we're given that AB is perpendicular to CB. So underneath the statements, now it's up to you. You can put all the givens right away, or you can do them one by one and check them off. So I'm going to put AB is perpendicular to CB. And so that means that angle B is a right angle. Okay, specifically you have to call it angle ABC. Angle ABC is right. Is a right angle. Okay, so number 1 was given. Okay, number 2, ABC is a right angle. So that's because perpendicular lines form right angles. You can abbreviate right RT. Okay, but then I check off that given, right? But now I have to use the next given. I have AD is perpendicular to DC. And I could have put in line 1, I could have put this line 3 as well, and then in line 2, I could have put what I have in line 2 and what I'm going to have in line 4 in a moment. So this is given. Okay, number 4, angle D. Well, I better name it with 3 letters. Angle ADC is a right angle. And again, that would be the same as line 2. See line 2. You don't have to write it again, okay? All right, anyway, so let me check that off. Okay, so then I have that angle 1 is congruent to angle 2. Okay, however, I have angle 1 and angle 3 are going to be complementary because I have a right angle here, and so's angle 2 and angle 4. So it doesn't matter which one I put first. I'll put that they're complementary first. So line 5, angle 1 and angle 3 are complementary. Okay, the same thing with angle 2 and angle 4. Okay, the reason for that is that a pair of adjacent angles where their non-adjacent sides form a right angle. Are complementary. Okay, so let me explain this. So you have in an angle, okay, angle 1 and angle 3, for instance. That is this yellow highlighting that I just did. That is an adjacent side, right? But the non-adjacent sides are AB and BC. So those non-adjacent sides form a right angle, angle ABC, and therefore angle 1 and angle 3 are complementary. Okay, the same thing with angle 2 and angle 4. Okay, but we already have that angle 1 is congruent to angle 3, so let's put that down. Angle 1 is congruent to angle 2. I think I said 3 by mistake. Okay, that was given. And so then we can say that angle 3 is congruent to angle 4. Similar to number 3 in problem 1, except they're complementary. Okay, so complements of congruent angles are congruent. Now, when I put the numbers in the picture for the angle measurement, I'm just doing that so that it's relatable for you. Okay, these pictures are not drawn to scale. So, check. I used all the givens. Okay, you have to use all the givens. And did I prove what I needed to prove? Yes. So I have angle 1 and angle 2, okay, which are congruent. So let's just say that they're both 40 degrees, for argument's sake. Well, since angle 3 is complementary to angle 1, angle 3 would measure 50 degrees. Since angle 4 is complementary to angle 2, angle 4 would measure 50 degrees. So angle 3 is congruent to angle 4 because think about it. These 50 degrees are both complements to the same measure because angle 1 is congruent to angle 2. Okay, so I hope that that makes sense. So in problems 3 and 4, pause the video, copy these down, Leave some space between them. So just like in the first video, I want you to have a side-by-side comparison of these two questions because it's all in the given. So in question 3, they gave us that AD is a perpendicular bisector. You need to use the given to head in the direction of what you want to prove. So it says here to prove that angle 1 is congruent to angle 2. So I start off, I have my statements, and I have my reasons. Okay, I only have the one statement here, which is that AD is the perpendicular bisector of BC. So you have to think about your goal. So your goal is to prove that angles 1 and 2 are congruent from this given, because the conclusion that you're going to get from this given has to lead you in that direction. So since it's a perpendicular bisector, we know that since it's a perpendicular bisector, we know we'll have a midpoint. Okay, that doesn't help us with the angles, right? So you don't need to conclude that. You can, but it's unnecessary. So instead, we're going to conclude that AD is perpendicular to BC, okay? So we have AD is perpendicular to BC. Okay, and that is definition of a perpendicular bisector. Okay, for now, you could just write a perpendicular bisector is perpendicular. Now down below, I'm going to show you this side by side. My given is different. So I have that EH is an altitude. Okay, given. But my conclusion is going to be the same conclusion I had in line 2. Okay, this is what I'm trying to show you. Okay, obviously I have different letters here. I have EH is perpendicular to FG. And my reason would be that an altitude is perpendicular to the line containing the opposite side. Okay, which is the definition of an altitude, right? Okay, so now either way that I have, these are perpendicular, either way, in line 3, I can conclude that I have right angles. So in line 3 on the top, I would say angle 1 and angle 2 are right angles. Down below, in example 4, I would say angle 3 and angle 4 are right angles. Okay, my reason would be the same as well, because in line 2, both of these proofs I had perpendicular. So the reason would be that perpendicular lines form right angles. So the reason on number 4 would be the same. Perpendicular lines form right angles. So then we can say that these angles are congruent for the same reason. So you could see that these proofs are very similar, but it's all in the given, how the proof starts off differently. Angle 1 is congruent to angle 2 in number 3. And in question number 4, angle 3 is congruent to angle 4. But the reason is the same. All right angles are congruent. Okay, so if you recall in video 1, I showed you that you have a given, right? You have a statement, and then that statement is used as a reason in the next line, right? So then we had perpendicular was our conclusion in line 2 for both of these. And then that fact that it was perpendicular was used as our reason in line 3. And then we had right angles, and right angles was used as our reason in line 4. So this helps you to see the structure of these proofs. Okay, so in example 5, again, pause the video, copy down the question, and then come back and play the video and copy down, pause, copy down as you go. So in example 5, I have that IL is perpendicular to KJ. And I want to prove that the triangle on my left and the triangle on my right are both right triangles. Okay, how many triangles are there in the picture? There are 3 triangles, right? Because there's also the outer triangle KIJ. So statements, reasons. So this time around I gave you perpendicular, IL, perpendicular to KJ. You want to prove right triangles, so you're going to want right angles. So in line 2, you're going to put that you have right angles. Angle ILK and angle ILJ are right angles. And the reason for that is that perpendicular lines form right angles. Okay, so notice I was given perpendicular, and perpendicular became my reason in line 2. So, number 3, since I have right angles here, I could say that triangle ILK and triangle ILJ are right triangles. In questions 3 and 4, I wanted to prove angles were congruent. So after I had my right angles, I said that the angles were congruent because all right angles were congruent. But in question 5 here, I'm not trying to prove that the angles are congruent. I'm headed in a different direction. I want to prove that I have right triangles. So I proved that I have right triangles, and my reason would be coming from line 2. Okay, but it would be a triangle with a right angle is a right triangle, which is the definition of a right triangle. Okay, by the way, just keep in mind that we have this pair of angles. Just keep in mind, this is still a linear pair for this angle. I'll call this angle 1 and angle 2, so it's easier for me to explain it. Those are a linear pair. We know that they're congruent, right? And when they're congruent, when you have a congruent linear pair, the lines are perpendicular. So just write that down. That hardly ever comes up, but you should be aware of it. Okay, if 2 lines intersect to form a congruent linear pair, then the lines are perpendicular. Okay, so we have some congruent linear pair. So we have just a picture, and we say these are congruent. Angle 1 is congruent to angle 2. We would be able to say that IL is perpendicular to JK. And this would be our reason. Okay, that concludes our second video.